will take a look at representing algorithms using pseudocode in the second video of the two-part video presentation about flowcharts and pseudocode. We saw that algorithms could be expressed as written descriptions in the algorithms video. Computer algorithms could also be represented using two other formats called pseudocode and flowchart or flow diagram. We will take a look at pseudocode here. Flowcharts are discussed in part 1 of this two-part video presentation. Pseudocode is written in plain English. It resembles closely to programming language, but it is not a programming language and does not follow any particular syntax. Programming language syntax is similar to grammar in English. Just like how you follow grammatical rules and punctuation in English language, each programming language has certain rules that the program written in that language has to abide by for the programs to work. Pseudocode helps you to focus on logic and efficiency, while designing algorithms to solve the problem without worrying about actual syntax of the programming language that would be used to implement the algorithm. Pseudocode does not directly run on a computer, but needs to be converted to a programming language. Pseudocode does not have a fixed format, and there are different variations or styles of pseudocode. You can use any of those or can even use your own style, as long as you are able to express basic programming constructs in it. It is therefore important that pseudocode should be written in such a way that it is unambiguous and easy to follow and easy to convert to a programming language. Let's now focus on writing a pseudocode with the help of an example. Let's use algorithm to add two numbers. Here is the descriptive text. We will discuss about variables in detail in a separate video, but let's just talk a little bit about variables before we move further. As we saw in first part of this two-part video presentation, variable is a container where you can store a value which could change during the course of the algorithm or program. Variable is given a name too, which is also known as an identifier. There is one more thing you need to know about variables in the context of pseudocode, and that is how you name variables in pseudocode. We will discuss variables in details in a separate video, but for now, it is sufficient enough to know that a variable is typically named as a single word in a pseudocode. So if you have to use a variable name, such as first name in pseudocode, then you form a compound word and write it in this way with F and N capital, or write it as F small and N capital, or write it as underscore between first and name with F small. Case is not so much important, as long as you name your variables consistently using one of the styles throughout the algorithm. Similarly, variable name number 1 in our algorithm could be written in the following ways. Let's now focus on writing the pseudocode. In the first two steps, we are storing the values 10 and 20 into the variables named number 1 and number 2. This could be written in pseudocodes as number 1 left arrow 10, or number 1 equals 10, or set number 1 to 10. Pseudocode often uses symbols shown here for assigning values to variables, but it depends on the style you have chosen. As you can see, some styles will not use any symbol, such as third style. We have shown here which reads set number 1 to 10. Same goes for number 2. Next step, where we are adding number 1 and number 2, could be written in pseudocodes as. Here, in the first two styles, we are using arithmetic operator plus to add two numbers and store the result in a variable named answer. Like flowcharts, the addition operation will be performed on the values stored in the variables called number 1 and number 2. Pseudocode uses arithmetic, relational, and Boolean operators to perform various operations. We will look at these in detail in a separate video. Finally, the step where we output the answer could be written as. Pseudocode often uses several keywords to indicate inputs, outputs, and process. Typically, these are written in uppercase, like the keyword output we have used here. Few examples are output, send, print, input, user input, read, set, etc. Let's see how our pseudocode for algorithm to add two numbers looks like. We will use first style for our pseudocode. You can use any style, but we advise you to be consistent in using your chosen style throughout your pseudocode. On your screen, on the left-hand side, there is a descriptive text, and on the right-hand side, there is a pseudocode. Let's now look at algorithm to calculate difference in numbers and write pseudocode for it. Here is the descriptive text. In the first two steps, we are getting the user to input first and second number, and storing them in the variables number 1 and number 2. These could be written as. In the next step, we are using selection construct. Here, we are asking a question and making a decision. Is number 1 equal to or bigger than number 2? If the answer is true, then we perform certain operation. If answer is false, that is when number 1 is not equal to or bigger than number 2, but smaller than number 2. Then we perform a different operation. In pseudocode, selection construct is described using if, then, and else statements or keywords. There are various statements such as if then else, while, repeat until, for next that are used to describe programming constructs like selection and iteration, and we will look at these in detail in a separate video. For now, let's briefly look at if, then, and else statements. If, then, and else statements are used to describe selection in pseudocode. If and else are also called clauses, that is if clause and else clause. Statements under the if clause are executed if the answer to the question asked in if statement is true, and statements under the else clause are executed if answer is false. You end the selection construct with endif statement or keyword, but in some pseudocode variations you don't have to explicitly write endif. In this step, we are using a relational operator, greater than or equal to check if number 1 is equal to or bigger than number 2. Here, we are instructing computer to perform comparison on the values stored in the variables rather than variable names. If number 1 is equal to or bigger than number 2, then we subtract number 2 from number 1. That is, subtract value stored in variable number 2 from value stored in variable number 1, and store the result in a variable called answer. Else, we subtract value stored in variable number 1 from value stored in variable number 2, and store the result in a variable called answer. We end the selection construct with endif statement or keyword. You can see we have used indentation here for if, then, else. It is often good practice to indent your statements in pseudocode to make it more readable. You need to understand that at any given pass through the algorithm, computer will only choose one of the two options. First option, which is statements under the if clause. If number 1 is equal to or greater than number 2, or second option, which is statements under else clause if number 1 is smaller than number 2. It is also advisable to use comments in your pseudocode to describe what a certain step in the pseudocode is doing. Comments are used to describe more complex operations to make it easier to understand pseudocode. Comments start with the symbol hashtag, followed by the actual comment. In the next step, we store the answer we got by subtracting one number from the other into a variable called number 3. This could be written as. Finally, we output the value stored in variable number 3. We can write this as. Let's now write a pseudocode for our algorithm to calculate cashback for credit card purchases. Here are the steps. In the first step, we asked user to enter the purchase amount and store that into a variable named purchase AMT. This could be written as. In the next step, we are using selection construct. Here, we are asking a question and making a decision. Is the value stored in variable named purchase AMT is greater than £500? If the answer is true, then we perform certain operation, and if answer is false, then we perform a different operation. We will use if, then, and else statements like previous examples to write this. Here, we are checking if the value stored in variable named purchase AMT is greater than 500. We are using relation operator greater than here to compare the purchase amount with 500. If the purchase amount is greater than £500, then we calculate the 5% cashback by multiplying purchase amount by 5 and dividing it by 100. If the purchase amount is less than £500, then we will set the cashback to 0. But before we do that, we will check if the cashback amount calculated in the previous step is greater than £100. In this step, we are checking if the value stored in variable named cashback is greater than 100. We are using relational operator greater than again to compare the cashback amount with 100. Here, we are using nested if statement. That means if statement within another if statement. This second if statement, where we are checking if the cashback is greater than 100, is nested within the outer if statement. If the cashback is greater than £100, then we need to reduce it to 100, as cashback cannot be more than £100. We exit this inner if statement with end if statement. You would have noticed that we have not used else clause for the inner if statement. Since we don't need to take any action when the cashback amount is equal to or less than £100, we don't need else clause for this if statement. Now, we add else clause to the outer if statement to express the case when the purchase amount is not greater than £500. We set the cashback to 0 in this case. We exit this outer if statement with end if. Now, depending on which path the algorithm has taken, based on decisions taken in the above two decision steps, the value of the cashback amount will either be 0 if purchase amount was less than £500, or cashback amount will be £100 if cashback amount calculated is greater than £100, as it will be reduced back to 100. Or it will be the actual calculated cashback amount if the 5% cashback calculated was less than £100. We then output the result stored in variable cashback. It is the value stored in the variable that will be displayed here, rather than variable name. You can see we have used indentation here again to make our pseudocode more readable. I hope you will now be able to write pseudocode for simple algorithms. Let's recap. Pseudocode is written in plain English. It resembles closely to programming language, but it is not a programming language and does not follow any particular syntax. Pseudocode helps you focus on logic and efficiency while solving the problem without worrying about actual syntax of programming language.